Hi guys, welcome to WissenWorld. This channel is for the people who are interested in learning new things in science and technology. To know more and to stay connected, please visit the links in the description below.
In this tutorial, you will learn about comparators and how they work using Op-Amp IC741. We also have an article on comparators on our website. So this is our article. You can find the link for this article in the description of this video. So what is a comparator? A comparator is a signal comparing device. It consists of two analog inputs and one digital output. So it compares the signal voltage on one input of a comparator with a reference voltage on the other input and then gives the output as 1 or 0 accordingly. So as you can see here in this figure, this is a basic comparator. Here a reference voltage of 1 volt is provided to the inverting terminal of this op-amp IC. And you can see here that we have connected a input voltage to the non-inverting terminal of this op-amp. So due to this arrangement, this circuit is called as non-inverting comparator. Now when input voltage here is less than the reference voltage, that is 1 volt, then the output voltage will be minus Vset, which is the negative saturation voltage. Now this happened because since Vin is less than the reference voltage, therefore the voltage at non-inverting terminal is smaller than the voltage at inverting terminal. Therefore output will be logically low and hence minus V saturation in this case. Now when voltage at non-inverting terminal becomes greater than inverting terminal, then output will be positive V saturation. So ultimately output voltage is changing from minus V saturation to plus V saturation, which is shown here in this figure. As you can see here, this is the reference line. When the input voltage is less than the reference voltage, you can see here when this input voltage is less than the reference voltage, then our output is low. And when this input voltage becomes greater than the reference voltage, then our output is high. Now you must be wondering, what is the use of diodes in this circuit? These diodes are used for protecting our IC from any damage due to any sudden excessive input voltage. Now what these diodes do is, these diodes clamp the voltage from the input in order to protect the IC. So these diodes are also called as clamped diodes. So this was our basic comparator. Please read our article, you will find a lot more detail here, like applications of the comparator and its characteristics and a lot more. Now let's move to Schmitt trigger. Here as you can see, this is a circuit diagram for Schmitt trigger. Schmitt trigger is also a type of comparator. It is also called a squaring circuit as it converts any waveform into a square waveform or a pulse. Here in this figure, we have an inverting comparator as a Schmitt trigger. Above, while discussing a basic comparator, we used a non-inverting comparator, and here we are using an inverting one. So in a Schmitt trigger, we have two threshold voltages, upper threshold and lower threshold. This input voltage here is compared to these threshold voltages in order to trigger the output of the circuit. What happens is, when the output voltage is at positive saturation, then the voltage at this point, or you can say the voltage across this resistor, is called the upper threshold voltage. This input voltage needs to be slightly more positive than this upper threshold voltage in order to trigger the output. So until the Vin is less than this threshold voltage, output will remain at plus Vsat. Now if we apply voltage divider rule here, we will get the value of upper threshold voltage equals to R1 upon R1 plus R2 into plus Vsat. Now when Vin reaches threshold value, output triggers and becomes minus Vsat. And the threshold here is now called as lower threshold voltage, and its value will be R1 upon R1 plus R2 into minus Vsat. Now our input voltages need to be slightly more negative than this lower threshold in order to trigger the output. So until value of Vin is greater than this threshold voltage, output will remain minus Vsat, and when it becomes less than threshold, then triggering will take place and output will again become plus Vsat, and then this cycle repeats. Now see this figure here. These two lines here represents the threshold voltages. This one the upper threshold voltage and this one the lower threshold voltage. Now if you see here, you can see that at this point our output is plus Vsat, which means we will consider the upper threshold voltage. So you can see here, until this input voltage is less than this upper threshold voltage, our output is at Vsat, and the moment the input exceeds this upper threshold voltage, our output is triggered, and now the value is minus Vsat. Now since the value is minus Vsat, we will consider the lower threshold voltage. Now until the input voltage is less negative than this lower threshold, or you can say input voltage is greater than lower threshold voltage, until that time our output is minus Vsat, and the moment our input voltage becomes more negative than lower threshold voltage, our output triggers, and now the value is plus Vsat. Now this cycle repeats itself. So this is a Schmitt trigger. Now let's see this circuit in Multisim. So here we have opened our Multisim software, and you can make your circuit here. For your components, go to this place component, and in groups you can select whichever group you want, and you will find the component you need. So I have already made the circuit of Schmitt trigger here. As you can see here, the value of resistor R1 is 10 kilo ohms and the value of feedback resistor is 20 kilo ohms. Here this is our operational amplifier, and here input voltage, we have set the input voltage at 10 volts and the frequency is 50 Hz. And this is our oscilloscope. So now let's turn on the circuit and observe our output. You can see here, this is our output waveform. Now you can change the scale values according to you. Now see these waveforms. It is clearly visible that output is triggering whenever the input voltage is crossing the threshold voltage. So we have successfully made our Schmitt trigger in Multisim. So this is it for this tutorial.
If you like our work and want to learn more, please support us by giving us a like and do share the video. Don't forget to subscribe and press the bell icon to get a notification whenever a new video is uploaded.